Welcome back to Physical Science 9 with Mr. Voigt. Today's lesson is on chemical reactions. If you recall, we started out second trimester talking about the atom and the periodic table. We then moved into our unit on chemical bonding, and we're going to take it one step further now and discuss chemical reactions. We have a long list of objectives here that we'll be studying over the course of the next 3 weeks, but the essential question, the thing that we're focusing on, remains to be what causes change. Now, we're going to see a lot of changes over the course of this unit of study, so it's important that we really think about what is causing the change that we observe. Now, chemical reactions, as we've alluded to in previous units, especially first trimester, is simply the formation of a new substance. And what's important is that that new substance has new properties. Now, today in class, we witnessed the hydrogen cannon, and we could see how when you combine zinc with hydrochloric acid, we could produce hydrogen gas. And then when we bottle that hydrogen gas up in a cannon, we can ignite it and make a very loud noise at the same time as shooting off this rubber stopper. So again, go home and explain the hydrogen cannon to your mom and dad. Explain what you saw and what you heard. And remember that the hydrogen cannon is possible because of chemical reactions. Now, first of all, how do we know a chemical reaction took place? There are certain symptoms that occur during a chemical change. First of all, a chemical change occurs, or we know a chemical change has occurred when there's a specific odor change. We also know that a chemical change has occurred when we see gas being formed. For example, bubbles. If we see solid formation, which is also called a precipitate, so if two liquid solutions combine and we get a solid from that, that's a chemical change. We also expect certain colors to form, but if we see a color that we don't expect, that is also an indication of a chemical change. And then finally, energy transfer. Now, energy transfer describes things like a beaker feeling hot or feeling cold. If we can feel heat or cold, then that means a chemical change has occurred. Now, a chemical reaction, again, is the process by which one or more substances undergo a change to become one or more new substances. And what's really important is that these new substances have completely different properties than the original substances. To give you an example of this, we can take wood and we can combine that with oxygen, and if we provide enough heat in the form of a fire, then we can change that into something new. The ash that's left over from a piece of wood burning is significantly different than the wood that it started out as. Chemical changes occur as a result of breaking and making bonds. To give you an example of this, we can see the reaction of hydrogen and chlorine. Now, here on the left, these little two blue spheres combined, that's a molecule of hydrogen. And these two green spheres are a molecule of chlorine. Now, in order for these two spheres or two molecules to become hydrogen chloride, we must obviously first break the bond between chlorine and break the bond between the hydrogens. And when we break those bonds, we can then make new bonds between the blue hydrogen and the green chlorine. Now, a chemical equation is simply a shorthand notation using chemical formulas and symbols used to describe a chemical reaction. What I have on the screen right now is an example of a chemical equation, and it reads HCl plus NaOH with the arrow, H2O plus NaCl. Now, a chemical equation is a very important piece of chemistry, because if you recall from first trimester, we talked about the SI system. We talked about the importance of making our communication and our language of science universal. Chemical equations are something that everybody around the world is familiar with, at least in terms of those that study science and chemistry specifically. So again, there are some pieces of this chemical equation that are important for us to understand. First of all, the plus sign means and. The arrow stands for react to produce. Okay, the things on the left of the equation, in this case the HCl and the NaOH, those are called the reactants. those are the things that the arrow is pointing away from. Those are the things that we combine to make something new. And the stuff on the right here, H2O and NaCl, those things are called the products. The arrow points to the products. So here we have the reactants react to produce the products. Now, it's great to have this shorthand notation, but you wouldn't read this as HCl plus NaOH arrow H2O plus NaCl. In fact, you would use the substituted terminology to come up with an equation that reads hydrochloric acid and sodium hydroxide react to produce water and sodium chloride. You can see that we start off with the reactants, which are in green. The plus signs mean and, the arrow means react to produce, and then our water and sodium chloride are the products. So again, hydrochloric acid and sodium hydroxide react to produce water and sodium chloride. This is again a chemical equation. Now I have many more examples of chemical equations. We have a variety of things, and basically anything that follows this format with a chemical formula, an arrow, and then more chemical formulas, that is a chemical equation. Everything here on the left are the reactants, and of course everything then on the right where the arrow is pointing to, those things are the products. Let's take a step back and recall what we've done in the previous unit in terms of the types of compounds. The types of compounds, whether they are ionic or covalent, they indicate for us what types of reactions might result if we combine them. So for example, there are ionic compounds, which is the combination of metal atoms to non-metal atoms. Examples of this include NaCl, MgO, BAF2, and Li2S. In each of these cases, the first symbol represents a metal. Sodium, magnesium, barium, and lithium are all metals. And then the second symbol represents a non-metal, so chlorine, oxygen, fluorine, and sulfur. Those are all non-metals. The second type of compound is a covalent compound, and remember that a covalent compound is the combination of non-metal atoms. Our examples of this include H2O, Cl2, HCl, CO2, CH4, and C6H12O6. Again, if we look at the symbols within each formula, we can see that all of these symbols are symbols of non-metal atoms. Acids is a type of compound that we haven't dealt with previously. And in all actuality, an acid is simply the combination of hydrogen with a non-metal or polyatomic ion. So in a sense, acids are predominantly covalent compounds, but they could be ionic compounds as well. Again, the combination of hydrogen with a non-metal or polyatomic ion. To give you an example, we see HCl, H2SO4, HBr, HI, H3PO4. The telltale sign of an acid is that it always starts with an H. We did mention here that acids can be hydrogens attached to polyatomic ions. SO4 is an example of a polyatomic ion, as is PO4. A polyatomic ion means simply that the PO4, or 5 atoms, are coming together to make one charged particle. Poly means many, atomic means atom, ion is a charged particle, so this is a many-atomed charged particle. The opposite of an acid is a base, and a base is the combination of a hydroxide with a metal or polyatomic ion. So again, if we look at our examples, the telltale sign of a base is this OH at the end. So NaOH, LiOH, CaOH2, KOH, and NH4OH. NH4 is another example of a polyatomic ion. That wraps up our lesson today on chemical reactions. Again, this was just meant to be a introduction to chemical reactions, and if we go back and take a look, we can remember that, of course, chemical reactions are the process in which one or more substances undergo a chemical change to produce new substances with new properties. We write chemical reactions using a chemical equation, and it's important for us then to understand the different types of compounds that exist within a chemical reaction.